Okay, good morning, everyone, and welcome to the Science Behind Sanitary Design, Food, Life Science, and Healthcare Facility Safety webinar. My name is Greg Jackman. I'm the Specification Program Specialist here at Watts. I'm also the host of this Watts Works Engineer webinar series. And today's installment, we've geared the content specifically for you guys, our engineer, architect, and specifier customers. Jimmy, next slide, please. So just to give you a little bit of a background on this webinar series, we hold several sessions throughout the year. They always cover a variety of topics. Our presenters are always our in-house technology product experts. And thanks to our partnership with ASPE, we're able to provide you the 0.1 ASPE CU credit if you stick around for the entire webinar. And that credit will be emailed to you in the next few days. Next slide, please. So after today, our next webinar will be on November 5th. It's entitled Solutions to Help Control Legionella. I am sending a link to the registration page in the chat window right now if you want to sign up right now, but we will be emailing you an invite to that shortly as well. Next slide. So we want to keep this webinar, as interactive and as engaging for you as possible. So during the duration of today's session, you guys will be muted. So if you want to ask a question verbally, we ask that you raise your hand. So the way you do that is you click the participants button at the bottom, and then underneath the attendee menu, you'll see the hand icon. So you can click that. Your hand will be raised, and then I'll unmute your line. Next slide. Obviously, we still have our chat feature here too. So if you want to submit your questions that way, that's perfectly fine. I see the chat question at the bottom right hand of the WebEx. Type in your question there. And we're going to do our best to address all your questions as we move along today. But if timing, depending on the timing and how quickly we're moving through the presentation, we may just save your questions till the end. Next slide. So with all that being said, I'd like to introduce you to the panelists today. First, we have Jimmy Hunt. Jimmy is our Business Development Manager for Liquid Drainage at Watts. He works with food safety and quality engineers to deliver hygienic drainage solutions specific to the needs and challenges of food processing, commercial kitchens, and bacteria mitigation. We also have Scott Garska. Scott is our Director of Global Accounts at Stonehard. Scott has been involved with hygienic construction practice for the past 25 years. And last but not least, we have Scott Steiner. Scott is our Regional Manager. He has a 20-year background in the design of plumbing and fire protection systems, and at Watts specializes in the Blucher line of stainless steel pipe and drainage systems. He's currently the Vice President membership of the Los Angeles Chapter and Education Chair for the Phoenix ASPE chapters, and has served for the ASPE Region 4 Director, Vice President of Membership, and Vice President of Technical for the Society Board of ASPE. So with all that being said, I'm going to pass it off to Jimmy to get started.
Good morning, everybody. Thank you for joining us in this oh-so-rare video conference. I'm sure it is not first. So good morning. I want to just discuss some of the learning objectives for today. We're going to identify the risks, particular to the health sciences and food and beverage industry from the drainage and flooring system. Now, I know that sounds like a fairly wide net, and it is intentionally, because as we're learning, drainage issues and drainage failures is not unique to critical and process areas. It is virtually any drainage system could help propagate bacterial growth, et cetera. We're going to dive into that. We're going to identify the effect of biofilms on the transmission and propagation of pathogens. We're going to analyze and evaluate the performance of drainage materials, identify the primary considerations when selecting drainage for an application, and describe the unique advantages and benefits of a stainless steel drainage system. So we're going to get straight into it, and we're going to play a video. All right. So sobering. So let's get started with talking about the healthcare industry. Scott Steinler, go ahead and take it away.
Well, good morning. Thank you, everybody, for joining us today. I was just looking through the attendee list here, and it's amazing how many people I know that are actually on this call today. And I really appreciate everybody showing up. So I'll just jump right into it, and we'll talk a little bit about HAIs. One of the things that I wanted to point out was the astronomical amount of money that's associated with preventable disease and preventable illnesses in hospitals. So there was a 2015 article in the Becker Hospital Review that cited at that point that there was about 96 billion to 147 billion annually in losses associated with hospital-acquired infections. So I took kind of a median number and applied an inflation rate to that. So in today's money, we're talking about $160 billion associated in HAIs. Now, if trying to wrap your head around the concept of a billion, most of us don't have a billion of anything. I don't ever anticipate I'll have a billion of anything. But to put that in some kind of perspective, if you were to line those dollar bills up end to end, you could literally wrap the earth 623 times. So it is just an absolutely astronomical amount of money to try to comprehend. It's more than the GDP of, I think, all but 29 countries on the face of the earth. So that's how much money we're spending on preventable illnesses. So it does, it does actually cause tens of thousands of patient deaths and billions of dollars in the healthcare system. Interestingly enough, under the ACA Act, Obamacare, the Centers for Medicare and Medicaid can literally penalize the hospitals for high infection rates by tying the reimbursement that they get to factors influenced by HAIs, such as readmissions, deaths, and patient satisfaction scores. They can get in trouble for falsely reporting those numbers as well. Additionally, they no longer reimburse hospital for direct care provided to a patient who contracts an HAI. So it's, again, it's an astronomical problem to try to wrap your head around. Jimmy, why don't you go ahead and advance, and I'll let Scott Gartzka talk a little bit about this one.
Sure. Thank you, everyone, for listening in today. This is actually part of, we do a presentation every year for different industries. I know that we touched on healthcare, but really it's a conglomeration of how do you reduce bacteria and what's the prevalence overall. And as you can see here, when Scott was talking about billions, really bacteria is pervasive. Really, we're about equal amount of bacteria that ourselves to human cells. So these are common things. These are not all bacteria should not be feared, but in certain spaces, how do we eliminate the risk associated with that? And so some of the items we're going to be going over today that Scott's talking about is how do you mitigate that risk and how do you control those variables? And I think what we'll see is, using the correct products and details are essential to do that.
Thanks, Scott. So it helps to think of, any kind of hospital or facility as a living, breathing structure, because behind every wall, under every floor, and every ceiling in any hospital or facility, you're going to find pipes. We often take an out of sight, out of mind approach because we really rarely see them. But these items are really can be described as a circulatory system of a building. They're delivering and disposing of vital fluids and gases in this living, breathing environment. But I'd like to give a little shout out to my friends at South Coast for allowing me to have this image in the first place. So thanks, Peter and Bill. I appreciate that. Scott, take it away.
As I said before, really, what are the variables in order that we can control the risk of bacteria? Really, it's some sort of organic matter. It could be almost anything at the right temperature. And if we include water, you pretty much have life. That's really the building blocks associated with it. The difficult part is, you can't control all those variables all the time. If you are in a food plant, if you're in healthcare, if you're in a pharmaceutical setting, there is going to be bacterial matter in the space, and you're going to have ambient temperatures. One of the critical things that you can control is the water, and that's what we're going to be talking mostly about today. How do you efficiently remove water from the space to effectively reduce the risk of bacterial growth and biofilm?
Scott, one of the interesting things you showed on that slide is the necessity of actually providing nutrition to the bacteria. And we're going to cover that in a later slide, but that's definitely one of the factors that most people don't account for in healthcare. We're going to cover that.
Exactly. And, as part of risk reduction, when you're looking at systems, really, what are the working surfaces within all these plants? Typically, it's the floor, the wall connection to the wall to the floor, and floor to the drain. So all the working surfaces need to be looked at. So if we can install seamless systems that are hydrophobic, and then really the critical piece is those details, which we'll get into, and how those details interact. Because what we'll see is, even if you pick correct systems, if the details aren't correct, if they can't work together effectively, then you have larger problems. So when we're looking at systems, we want to make sure they're non-porous, they can hold up to the chemicals or the temperatures within the environment, that they're impact resistant and overall easy to clean. And part of that thing with cleaning that we'll talk a little bit about is, if we can reduce the amount of water in the area itself, we can also reduce the amount of risk from bacteria. And one of the ways that we try to get rid of water effectively in a lot of different areas, whether they be healthcare, life sciences, food facilities, is to effectively, in some cases, pitch the floor to get the water out or evacuate the water to the drain, and have the drain be a hygienic system as well, to remove any types of fluids as quickly as possible. Many times what we'll see is porous materials being used as grout materials, or incorrect details, which you can see here in this picture, where they used incorrect details, they used poor pitching material, and they used improper drain placement, so you have pooling water. Anytime you have pooling water in whatever type of facility you have, you've already established one of the key building blocks to create bacteria. How do we reduce that? By proper drain placement, using better drains, and making sure the floor connection is adequate as well.
All right, so now it's time to talk about the combination of plumbing and disease. So obviously we can't have this discussion without discussing COVID at this point. So research has demonstrated that there are certain strains of bacteria that will colonize microbial biofilm communities in a sink P-trap or drain. Usually they're antibiotic-resistant organisms, and they do not appear to amplify unless they are supplemented with liquid waste containing microbial nutrients. These can include soft drink products, intravenous fluids, or nutritional shakes. So as I had mentioned earlier in Scott's slide, we were talking about the necessity of providing nutrition in order for these things to propagate. In a hospital, there was a study that was done out of the UK that showed that a very, very small percentage of the hand sinks and the lavatories in hospital rooms are actually used. Instead, they're finding that these are used by the nursing staff, and what they're doing is disposing of soft drinks, food products down that drain. So we are spreading and feeding these drug-resistant microbes in this biofilm by disposing of fluids down the drain. So this is actually a reminder of the 2003 SARS outbreak, where the building sewage pipes, we're drawing the comparisons between that outbreak because of the spread and the propagation, which resulted in 300 infections and 42 deaths due to poorly designed plumbing systems, which allowed the spread through the building complex. All right, so we'll go on to the next one. Jimmy already brought it up. So we're talking about that pathogen transmission. I see that there are many, many plumbing designers on this call right now. So as you're aware, and I've seen a lot more of this, that they have moved the drain location from the center of the sinks. They're now in the back corner for this very reason. What happens is the microbes start growing in the P-trap of the drain, and these things can grow up to about 5 millimeters per day and spread from P-trap to P-trap to P-trap down a waistline. And what happens is when you dispose of water or any fluid down the drain, it aerosolizes the bacteria that's in the drain and it splashes, similar to what we've seen with the water closets when they flush and then the air kind of spreads it and disperses the pathogens throughout the room. Jimmy, go ahead and advance. I think we could talk about that a little bit more. Oh, yeah, so let's talk a little bit about that. So testing wastewater, and, again, we have to talk a little bit about COVID-19 and what's going on in today's environment. So what they've figured out is there's a process called shedding where you dispose of the virus. Anything or any bacterial growth or infection that we have in the human body, we're going to dispose of it as
in the form of our waste. So what they've done over in Tempe, Arizona, is they've started sampling community wastewater. So the shedding process occurs, the community wastewater goes to the wastewater system where it's sampled. The sample is sent to the lab, and the sample is analyzed for the presence of COVID-19. Jimmy, go ahead and advance. So this is Tempe, and this is what ASU has been doing. And what they've done is analyzed and kind of taken a look at how much COVID-19 is in the community by sampling the waste stream, which is interesting. And that resulted in there was a condition where 2 people at ASU were asymptomatic in a dormitory setting. And through sampling the wastewater, they detected the COVID-19, went through, isolated the 2 patient zeros that had it, and managed to curtail the infection before it spread throughout the entire dormitory. So this has proven to be very effective, similar to the way they've done this up in the northeast portion of the country, where they were trying to analyze how pervasive the drug abuse problem was with the narcotics. I think they were sampling wastewater up there. So it's kind of an interesting process how they do this. Jimmy, go ahead.
Scott, are you going to talk about how we can prevent that?
How we can prevent what? The spread of the propagation through the plumbing systems? Yes. Absolutely. We're going to cover that later on, and we're going to talk about a little bit of the metallurgy and the process and resistance to biofilm formation in the piping systems. But that's going to come down when we get into the solutions there. Just kind of wanted to show you a little bit. This is a CDC slide showing where the pathogens do appear in the drainage systems. And if you would go ahead and advance again. So here is a list of some of the microorganisms and where they are found in the drainage system. So you can see that most of it has to do with drains and traps. There's quite a bit that's in the piping systems as well. But again, really the introduction point is through drains and traps. With and again, this could include Legionella. This is SARS. This is many, many other things that I can't pronounce, so I'm not even going to bother trying right now. And I think we're at a break. So are there any? Oh, go ahead, Jimmy.
Yeah, so that sort of covers healthcare as a macro. And like Scott had mentioned, we're going to get into some more details on what we can do to mitigate that risk and spread, not only in healthcare, but virtually anywhere where you have these connection points with drains and floors and walls, et cetera. So, Greg, are there any questions we want to address now?
No questions have come through, so just a reminder to raise your hand if you have a question now on your line, or you can submit them in the chat box. So we're good for now.
So now what we'd like to do is move on to the food and beverage industry. So go ahead, Scott.
Actually, Jimmy, why don't you talk about this? This seems to be your forte. I know you and I have talked about this quite a bit, and I'm sure you have an interesting perspective on it.
Well, I'm just a moderator.
You're just the moderator. Okay. Jimmy's just the moderator today. You are a subject matter expert there. Okay, so we can talk a little bit about how severe the food contamination is. So we know that every year food contamination and foodborne illnesses sicken and kill thousands of people. Now, I do want to stop right here. At one point, it was mentioned that we're implementing fear-based tactics to kind of spread this news. But I just kind of want to put an end to that. What I'm trying to do is convey information and let you know how severe the problem actually is. These are not numbers that I'm doing. We're not seeking to do this for any sort of profit, but I'm trying to bring this to the attention of really the plumbing designers and the facility owners, because there has not been a whole lot of correlation between the drainage system and the problem. I mean, as a 20-year designer, I don't think I heard this story until I came to work for Watts. So it's important that people kind of try to wrap their head around this, and we bridge the gap between the two or even three industries, so people are understanding bigger picture what's going on. So
yeah, and I think, Scott, to your point, everyone has heard of food recall. It happens all the time. People are getting sick. You can see some of the statistics, but to your point, we're not trying to fear-base. What we're doing is raising awareness, to your point. And so these are serious things that exist, and I don't know that many of the audience are aware of the fact that so much of these illnesses are actually originating on the floor and in the drains, and why having the right drainage system can mitigate that risk.
Well, let's talk a little bit about the cause of the food recall first. So go ahead and advance to slide 23 if you don't mind. So when you're talking about the causes of food recall, this is information extrapolated from the Food and Drug Administration. You can clearly see that the two leading causes of food recall in the U.S. are due to allergen and microbial. Now, allergen can be something as simple as a undeclared allergen like milk, nuts, things like that. I'm sure people see a lot of undeclared allergen type of things. But secondary to that of a bigger problem is microbiological. So let's go ahead and advance, and we'll talk a little bit about this whole genome sequencing. And again, this is where the science really comes in and the fascinating part of what we do. I was at a conference, food processors, and there was a lady speaking, and I found this absolutely fascinating how they're doing this. So let's say Jimmy Hunt gets sick from going to the hat, which can happen, Jimmy. Thanks for that. So Jimmy goes to the hat and he picks up a bug or something like that.
Delicious. Worth it.
It is many things. Delicious is not the word I would use, but either way, so you go to the hat or whatever, you're having dinner at home and you pick up some sort of foodborne illness that results in you going to the hospital. The hospital takes a pathogen sample from you. They know that this is a foodborne illness, and then they analyze these pathogens through whole genome sequencing. So let's say I have listeria. They're going to go ahead and they're going to sequence this RNA sequence or DNA sequence, depending on the pathogen that you're dealing with, and they enter it into a database. At the same time, there's inspectors out in the fields and they're swabbing drains and they're doing all these different things at food facilities. And if they detect a listeria or some sort of pathogen there, it is also subject to this whole genome sequencing, and it is also added to the database. So you could have a facility here in California that's producing, let's say, lettuce or some sort of poultry product, and then a guy back east has bought something that's come out of this particular facility, and they're able to match the pathogen and its source. So they're able to backtrack it. So it's an absolutely fascinating thing that they're doing with this genome sequencing to actually track down, locate the source, and put an end to it.
And when you talk about sources of the bacteria, that's what we're going to get into a little bit more in these slides. But everybody's heard of salmonella and E. coli, but you mentioned listeria. So talk to me a little bit about listeria and food recalls.
So just to jump in for a second here, we had a question come through. Can the pathogens contaminate the air from direct drainage? If so, how does that happen?
Pathogens contaminate the air from direct drainage?
Yeah, can pathogens contaminate the air from direct drainage?
Oh, if the plumbing system is sealed, yes. So instead of, I think what the question is, and I don't know who asked that question. So there's direct and indirect drainage systems. So, if it's hard pipe from, let's say, your sink to your wall, and if there's no air gap or air break or anything like that, then that would be, I think that's what they're referring to as a direct drainage system, as opposed to an indirect where you would have an air gap in a floor sink and maybe it would be discharging into that. The answer is yes, it can absolutely translocate through that methodology, because you are breeding the bacteria or pathogen in the drainage system. It gets up into the drain. Now, because we know that, once you put something down the drain, it doesn't go away. If you have high winds outside, I don't know how many of you have worked out in the field and you've heard a bubbling P-trap or you smelled hydrogen sulfide, whatever phenomenon occurs to actually dry out the drain trap, then that pathogen has a pathway to the facility. Oftentimes, drain cleaning, which we're going to cover, is one of the leading causes of translocation of the pathogen. So the very act of trying to prevent the pathogen is what's causing the spread. So we'll cover that a little bit, but that's a very good question, and I think that's what they were asking. Can you see in the Q&A if maybe that did address that? In the meantime, I'll go ahead and I'll talk about listeria a little bit. So you can see that really the leading cause of microbiological issues from that standpoint is listeria. Dating back to 2014, you can see, the number of cases was 855, and in 2015, 647. So the very, very high percentage of that. And the only time that's really flipped seems to be in the later years, and I kind of chalk that up to early detection methodology, where they are able to do instant swabs. You're able to actually go out and get samples and determine instantly if there's listeria present, whereas before, I believe, it required a laboratory process, which is why it was more prevalent at that time.
Right, and that's the food FDA numbers. This is the USDA numbers.
Right, and the FDA applies to food, tobacco, medical products, and the USDA is specific to the production and packaging of our commercial food supply. And you can still see that, constantly, except for 2016, Listeria has been the #1 cause, but everybody usually thinks of E. coli or Salmonella, and while they are bad, it's not to the same extent as the Listeria and not as consistent. Let's go ahead and
we talk about the origins of this bacteria, and Scott Garsko, why don't you talk through sort of where this stuff is coming from and how it's getting on our food?
Sure. Listeria specifically is difficult because it's kind of like, once it's in your facility, it's like a cockroach. It's extremely difficult to kill, and the root source analysis really becomes critical. And I agree wholeheartedly with Scott. It's almost always the case where the individual trying to clean the problem actually creates the problem, where you aerosolize, in many cases, the Listeria, and now it's everywhere, or you track it around your facility. And it's almost always due to the methods in which we clean. Many of the largest food producers now are looking at ways to mitigate that by reducing the amount of wet cleaning done in facilities and the methods in which they do it. Because if you don't look at the root source analysis, there's always going to be things like Listeria on the cleaning equipment or in areas of transition details. So almost always it's going to be root source analysis in the drain, and then any connections from the drain, usually the drain to the floor, just because you have dissimilar materials meeting together, or the floor to wall interface. So anywhere a material is starting and stopping, if there's a gap, that's a place for life to occur. And once they do that, once they start trying to clean it, the next thing you know, they're using high pressure water, and you've now aerosolized the Listeria to stick on different types of surfaces, such as walls and actual food itself.
Well, and it gets into conveyors too. I believe there was a facility that they got Listeria into the conveyor system, and it was passing through the structure, and it got into the building insulation. So the entire structure had to be sanitized. And the interesting about that, I used to have a slide. I don't know if there's any Star Trek fans in the presentation today. I used to have a slide that had Captain Kirk on it, and I called the drain cleaning slide the Kobayashi Maru, because it's absolutely a no-win situation. Go ahead and advance.
Yeah, so we've come to a break point. If we have any questions about food processing and bacteria growth and propagation, in our food supply. Or was there clarification, Greg, from the previous question?
No new questions, and that person who asked the other question didn't follow up. But so I think the answer is sufficient.
Excellent. All right. Well, so now we've kind of talked about the problem and raised some awareness of the multitude of issues that are being caused in the drainage system. So now I want to dive a little bit deeper into some of the reasons why. So Scott, take it away.
Hey, Jimmy, can you mouse over that picture in the lower right corner? Don't click on it, mouse over it and see if it moves. That's actually a little video there. I don't know if it's going to work on this presentation. No. Oh, that's a bummer. This one actually had to do with the item 7, which was the load rating, where the customer told me it was only going to be foot traffic, yet you can clearly see this forklift running dead center down the trench drain, carrying a piece of equipment. I always found that one to be funny. They posted that on social media. That made me laugh.
Yeah, it's an interesting point, because you hear a lot like, oh, we don't need a heavy-duty grate for this because it's just going to be foot traffic. And that may be true after the 20,000 pounds rolls over.
Yeah. Did have a question come through right now. You mentioned microbial risks. What about mycotoxins, which are categorized as chemical risks?
I'm not really sure what that would be applying to. Would that be something in the waste stream that they're disposing of?
From molds?
Well, that's still a biological process. And the molds, I think, would be more of a Scott Gartzke issue with the seams and the corners of flooring systems. I don't know. Go ahead.
It's an after effect, and it's even more of an issue, because they're already prone to be airborne, in a lot of cases, and it's also a sensitizer if you're talking about mold and spore contamination. So it's in the same vein. It really is dealt with in the same manner. Effective cleaning processes, making sure you have effective drainage to get the bacteria or contaminants out of the area. It's really the same solution. It's just a different causality overall, but much the same.
That's interesting because there was also an issue with yeast when you're talking about like the beverage industry. When I was up in Northern California a couple of years ago touring around, and they would not allow me to step foot into a winery if I had been into a brewery prior to that. Not because of molds, it had to do with yeast, because a simple yeast can get into their system and wipe out an entire batch of wine.
Sure.
So, and it's also, again, like you're talking about, it's the same thing. You want to have that drain clean and dry. Otherwise, you get these wild yeast blooms, and that can wipe out an entire industry's worth of wine. So talking a little bit about biofilms, which was one of the issues, biofilms, they've been connected to about 80% of the bacterial infections in the U.S. You can go into your shower, you can feel a handle. Biofilms are there. Now, biofilms in and of themselves are not really a problem. Not all biofilms are created equally. So what happens is you get these bacterial cells that adhere to the wall of a pipe. They excrete a slime layer. Inside of that slime layer, that's where those opportunistic pathogens can really spread. And then you get more layers of the slime. There's actually a technical term for it. What do they call it? Something gross. I don't even like using the word. But either way, you can get these, further layers of the biofilm on top of it. So you get this antibiotic property where you can't actually clean it. And then these colonies will break off and they'll propagate throughout your piping system. Go ahead, Jimmy.
So, Scott, we had another question come through. What do the bacteria feed on in areas such as the building itself?
See, we're talking about, again, if we're talking about the two specific industries that we're discussing today are food and beverage and healthcare. So food and beverage, it could be, I've been to sushi factories where they're just dumping massive amounts of fish and rice down the drain. It could be, your Kellogg's where they have cereal bars going down. It could be a hospital where they're dumping soft drinks, nutritional shakes, body fluids, unfortunately, sometimes end up down there. So that's your nutrition source, to answer that question.
And the harborage point, the main one in any plant or facility is concrete. So if you can cover up the concrete and keep it dry, then you're eliminating a petri dish overall. So that's why those drain connections are so important. If you might have just a very small hole in that transition between the floor and the drain, and the next thing you know, underneath it, you've created a nice little environment for bacteria to grow and replicate. And if we can eliminate those, that's really the critical piece.
Yeah, I saw a little comment come through in the chat from Tony Carver. I do like the Trouble with Tribbles reference, but additionally, he was asking about body fluids. So yes, there are actually body fluids that end up in the drainage systems. If you're talking about an OR, although the drain is gas tight, you don't necessarily have an open drain. At some point, they come in and they do sanitization, and that you can, although they are supposed to wipe up, whatever fluids end up on the floor. Dental clinics, again, could be anything. It does end up down the drain unintended, but it's not supposed to, but sometimes it does happen. So to talk about that a little bit more, and to give you an idea of how small these soil microorganisms are that we're dealing with, they have a deeper penetration rate in weld seams and crevices than water. This chart always makes me laugh because apparently beer is a pretty good cleaning agent, much better than water, better than milk. And then there's this quartz, which is a kind of industrial cleaning agent. But even those don't penetrate deep enough to wipe out the soil microorganisms that get down into the piping systems. Go ahead and advance, Jimmy. So we'll talk a little bit about that. So one of the things we've looked at with stainless steel systems is the resistance to the biofilm formation. So contrary to where my head was at with this, PVC rates very poorly in terms of biofilm formation because although it has a very, very low coefficient of friction, it is a very porous material, and you can kind of see how these things are rated. And this was extrapolated from an article I found online. Basically, effects of diverse water pipe materials on bacterial communities and water quality. So really interesting article. I can provide these things for people if they want to look into this a little bit further. What I found
So
really interesting, I'm sorry?
The more porous environment you have, the more likely you are to build the biofilm formations, the more likely you are to get bacteria to grow within that porous environment.
Well, that's what Scott was talking about with the concrete and how poor that rates. Because a lot of places, even out in the market, we're seeing these kind of preformed concrete trenches, and they put that what's the lining they're putting in there, Scott? They're like in a net. What is that?
There's different, different methods they use. And I think conceptually, a lot of people think in plumbing that, all right, I replaced it with PVC or a resin-based trench liner, and in actuality, they've done something to incorporate a system that's more porous than what they had before. Clearly, cast iron is porous in many cases, but the gold standard is stainless steel. And we trying to use, especially in the food and beverage industry, and any critical care, or if it's life sciences where you have bacterial contamination, whether it be human or animal waste, stainless steel really is the way to go, just because of the porosity of it. And as Jimmy said, the advance of biofilm over time. And it's really racing against the clock. If we can mitigate the risk associated with biofilm growth, as you mentioned, as much as 3, 4, 5 millimeters a day, you can grow biofilm. It doesn't take long for you to have a massive problem in a facility.
Scott, a question here.
Go ahead.
Sorry to interrupt. Can you go back one slide? This question is just around asking about where the cast iron is on this chart.
Cast iron is secondary to PVC, so it's best to cement and cast iron.
Okay, thank you.
Yeah, and that's not to say that you're guaranteed to not get biofilms on stainless steel, right? It's just that's the least porous environment, so the least likely to build biofilms.
Okay, so here's some pretty good examples of pipe corrosion. The one on the left is fascinating. That's actually a vertical vent pipe, and you can see the trickle effect of the acid coming down the piping. And the one on the right was mic corrosion, where the piping wall had been eaten so thin that I was able to tap that hole in there with the tip of my finger just by giving it a little smack. Go ahead and advance. So we'll talk a little bit about that. So when we're talking about hydrogen sulfide, and that's, when you have the dry trap, you smell it. It smells like rotten eggs. But what it really is hydrogen sulfide gas. So if you oversize your pipe or whatever reason you don't have enough velocity in your piping system, you get a deposit of solids in the bottom of your pipe. And then bacteria are in there, and there's this anaerobic process that occurs, which results in the off-gassing of hydrogen sulfide. Well, that is lighter than air, so what that does is that comes to the truss of your pipe, condenses and forms sulfuric acid, which on that vertical pipe, because the vent pipe, kind of tilts back in towards the waste system, and it resulted in a constant trickle of sulfuric acid running down the piping system. So this is corrosion that's caused by hydrogen sulfide. So it's not just an odor problem, it's a physical problem to your piping systems. Very, very prevalent in the municipal systems in Vegas, for example. Go ahead and advance, Jimmy.
We're now at another break. We've kind of identified some of the origins of the bacteria and some of the issues concerning weld points and porous environments. Any questions, Aaron?
Yeah, we had another question here. Are all plastics considered to be poor rather than just PVC?
No. To answer that plainly, I mean, there's many, many thermoplastics out there. I don't have enough data, and I have not been able to locate enough data, but there's things like polypropylene, polyethylene. I think there's even different types of PVC that are out there. There's many different things. CPVC, which may be perfect for one application, but not another. So that was just a broad kind of stroke overview of where everything is, but it's certainly not all inclusive of all plastics. And it's not even inclusive of all stainless steel, because there's different grades of stainless as well. So when you're talking about acid resistance and things like that, there's a lot that goes into it.
All right. Any other questions, Greg?
Yes, but I think we should keep moving along in the interest of time here, and we can address them at the end.
Absolutely. So we'll talk a little bit about, just in healthcare and critical areas about the different features and benefits to the stainless steel, like in particular push fit systems and their cost competitiveness and how their joint systems work, ROI, acoustical considerations. So let's go ahead and advance right away. So one of the critical areas that's even been pointed out in the NIH design policy and guidelines, I see that there's a few healthcare designers on here, but they are very specific that the architect engineer, you should specify your drain and piping connections that are compatible with your piping system, because that often becomes a problem and a leak point for you. So just a reminder on that. Go ahead, Jimmy. Talk a little bit about acoustics. So here's just your basic acoustic chart, ranging from everything from a jet plane to falling leaves. And we'll talk about how the systems work here. So in particular in healthcare, the level of background is referred to a series of noise criteria or room criteria curves. So over the years, the NCRC levels, they've been established through processes to kind of determine what's critical for, patient comfort, executive offices, classrooms, things like that, to establish what's going to be an acceptable noise level. So the range of 20 to 22 for the stainless steel pipe shown on the previous slide is well below the decibel thresholds established by the NIH for NC and RC levels, except for in places like auditoriums. But even then, there's things that you can do in terms, it's actually good there too, because if you look at the equivalent sound level in decibels, that anywhere from 20 to 22 for a properly anchored and secured piping system is well within the norm. It's right up there with other piping systems. And it's important to point out that the piping systems themselves are not really that resistant. The usual source of the sound transmission in any area has to do with how the piping is anchored to the structure. It's the structure that resonates the sound. It's not the piping system itself, if that makes sense. It's how it's attached to the building. Any questions on that?
All right, so now we want to get into some specific applications, get a little bit less general, a little more specific. So let's start with this slide, Scott.
Oh, okay, yeah. I mean, you've just basically touched it. We're just talking about the drainage to match specific applications. So we have laboratory piping. Now, this slide used to be really cool. That thing would scroll, and it had just this monster list of things that 3/16 stainless steel is compatible with, but it doesn't seem to work in these settings very well. But stainless steel is resistant to a lot of the chemicals and cleaning agents that are found out in the market. And again, this applies to not only healthcare, but to the food and beverage industry. We'll talk a little bit about the critical areas. So if for some reason you have to run over a mission critical area, you're capable of doing dual containment. So pipe and pipe systems in stainless steel are available, as well as, in the plastics, but we're talking about stainless today. Go ahead, Jimmy. Vacuum systems. Our friends over at Acorn Vac were kind enough to provide us their image. So those of you that are familiar with it, vacuum piping systems. You can see that the gravity toilet kind of spews the pathogen throughout the facility during the flushing process, where in vacuum systems it does not. And then there's other areas such as like radioactive drainage water from oncological treatment areas. So what you could do is actually extract that water. So if somebody's going through radiation therapy, again, we talked about that shedding process. Any problem you have is going to be discharged from your body. So if you have that problem, you can actually pull that through a vacuum system to a central disposal point where it's not intermingling with something that's going back to municipal.
All right, much of what we've talked about so far has been really sort of revolving around flooring and piping. Let's dig a little bit deeper into drains and trench drains and the risks associated there.
Yeah, do you mind taking that one, Jim? I mean, you want to talk a little bit about continual use temperatures? It's actually pretty clear to see. I mean, you've got your continual usage temperatures here for various materials. And again, you also need to realize that the limitations generally placed, and you can see that stainless is up to 212. It's the second one from the bottom. So at what point...
Now, that's not actually stainless steel. Stainless steel can withstand a lot more than that on temperature. I think specifically in this slide, it's to do with an EPDM gasket that's installed in the hub end of the push fit pipe, right? And that can be up to 400 degrees.
Right, but then at some point, water doesn't become water anymore when you heat it up enough. So
Right. Good point.
You do flash, and then you're not even dealing with like a liquid discharge anymore. You're dealing with the steam, and I don't want steam in our pipes. That's not what it's for. So.
Yeah. So I think the most important slide here as it relates to the flooring and the drainage is the thermal expansion. So Scott Garska, talk to us about thermal expansion and significance of drainage and bacteria growth.
Sure. One of the things that we see all the time is, somebody will specify a drain and specify a floor. Unfortunately, those materials may be incompatible, especially if there's elevated temperatures. So as there's heating and cooling going on, the issue would become, you're talking about two rigid systems that expand and contract with different thermal rates of expansion. So the ideal situation is to specify materials with similar rates in any type of situation where you have an elevated or reduced temperature from ambient. So the critical thing is here, as you'll notice, that stainless steel and concrete act about the same. They're nearly identical in terms of thermal rate of expansion. The issue is some people will try to put in, especially when trench frame materials, put in plastic-based ones, which expand and contract much more quickly. And in an elevated situation, they will delaminate from the surrounding flooring material.
Yeah, we're going to show you that.
Crack.
We've actually got a slide really that displays that very clearly in about 5 or 6 slides. So we'll get there.
Yeah.
But the point is that as you have the larger thermal expansion rate, you become separated between the drain and the floor, creating a gap that can then grow bacteria a lot faster. But to Scott Steinler's point, we're gonna get to that in a further slide. So go ahead and talk a little bit about life safety before our next break.
Okay, well, we'll talk about life safety. So we are all aware that evacuation of a hospital takes longer than evacuation of a traditional building. Same is actually true in marine, but we're not talking about marine today. But it's, again, same issues kind of span various markets. So we know that the drainage pipe work, since it's a non-water-filled piping system and it passes through different fire compartments, it really should have the highest fire rating available. Stainless steel has all the best fire safety characteristics and is really the preferred drainage on board cruise ships, where safe evacuation of passengers is critical. So the same consideration goes into the hospital environment. It is important to note that stainless is non-combustible and as such is exempt from the ASTM E84 and UL 723 tests for surface burning characteristics of building materials. It does not produce smoke or gases from paint or additives, doesn't produce any burning droplets to spread the fire downwards in the building. And additionally, excuse me, I'm sorry. I had another thing on there. What I was talking about, and you see the threshold drain on the side. So this is really out of the California Building Code, and that has to do with the drainage of water from the threshold, so you don't get water into the elevator hoistways, because those hoistways are critical to firefighting operations. So there are stainless drains. Many people manufacture these, but those stainless threshold drains are available, and they're fire resistant. Go ahead, Jimmy. Sorry about that. That one threw me for a little bit there.
I think we've got a little bit more content. We've got a couple more sections. The next section is really around stainless steel, specifically with passivation and things. And then I'd like to spend the most of the rest of our time discussing the flooring issues and the drainage and trench we had alluded to earlier. So Scott, just real quick, talk to us about this. Yeah,
this is kind of a high level, just a reminder that stainless steel does help to mitigate the bacterial and virus propagation and reduces your risk of HAIs. It is the preferred piping material, kitchen, grease waste, laboratories because of chemical resistant, even sanitary waste because of its resistance to hydrogen sulfide. Once you put the systems in, you're not constantly having to worry about them rotting out of the wall. Vacuum systems, anywhere where really that corrosion resistance is required. And again, we talked about the fire safety. Talking a little bit about the jointing methodology, push fit versus welded. It's a quick install. You can get in and out of these facilities very, very fast and keep your project moving. You can handle the heat expansion in the socket, so there's not a risk of a thermal cracking due to the hot and cold that Scott had talked about earlier with the thermal expansion and contraction. Most of the welds that the manufacturers do are made in a factory with the protection gas, the inert gas inside and outside of the piping system. so you don't have the same problem with the corrosion and the removal of the chromium oxide, which is really what happens in the field. You see these beautiful 3/16, welded systems in food and beverage. We see them a lot. So you take this incredible, stainless steel material, take it out into the field and you weld it, and then if you see on that welded joint that beautiful rainbow hue, that means that your stainless steel pipe's no longer stainless. What you've done is you've removed the chromium oxide, and every joint that you weld in the field becomes a possible corrosion point. And it's very difficult to do, very slow, requires not only skilled labor, and if you're talking 10, 12, 14, even 16-inch pipe, you're not generating very many of these welds a day as opposed to a push-fit system. And again, very expensive to do. Then there's the passivation process. So there's chemical passivation, which has to occur in the field, and then there's acid passivation. Acid passivation is a much better method of cleaning the welding slag and the dirt and all the contaminants and scales off of the surface of the pipe, which really helps. Once that's removed, it really helps the formation of the protective film, which is the chromium oxide. Out in the field, that is very difficult to accomplish using chemical passivation methods. Go ahead, Jimmy.
Greg, are there any questions before we get into our final section?
Sure, we can knock off some questions here. So going back a few slides, so house garbage disposal systems must be the worst for generation of bacteria. It's more of a comment. Question here, where did copper piping land on the list of piping materials?
It's not rated because you typically don't see very many copper drainage systems. So I didn't
but
even.
It is fair to say that copper is probably more resistant to biofilm. Bacteria don't tend to stick to it, and so a copper drainage system, I've been proposing for quite some time. It makes a lot of sense, but it was not on that list, and I suspect it's probably less susceptible than stainless, but you're not going to find a lot of copper drainage.
I don't know if that's actually the case. That would be interesting to look into, because I know that it's still on the supply side. There's still a problem with Legionella, and I know that there are biofilms in copper piping systems. So it'd be interesting to see how it rates up against it, but I don't think it would be something that we would see in that market.
It is something we're investigating, though. But yeah. All right, so Scott Garska, let's talk about these common issues and sort of what's happening in each of these images and why and how we can solve it.
Sure. So regardless of the type of facility, it really comes down to critical control points, where we're starting and stopping dissimilar materials or if there's damage over time. So these pictures pretty much are illustrative of different types of problems you'd see in almost any facility. Bad details in terms of termination of cove, or selecting the wrong systems based on temperature and chemical exposure. Sizing the drains correctly is something we see all the time, where the function of a room may change over time. They're dropping a giant kettle of one product that before they had a smaller kettle, and all of a sudden the drain overflows, and now you've got bacterial contamination all over the floor, and your people are walking it or tracking it around the facility. And now you see things much more common using peracetic acid-based cleaners pretty much to deal with those types of systems. And then really the termination points when you look at how you're putting your drains in. Anytime you have a 90-degree angle in concrete, it's not if it's going to crack, it's when. And it will crack on a diagonal. So if you're using square drains or square area drains, I would just caution you need to have relief from those in terms of the correct details, because they will crack over time. The way to get around that is using round drains or better trench drain systems in general.
Right, because you can see not just the square drain, but the rectangular trench on the bottom left. I can see that stress crack between those two corners, and that's an exact result of that thermal expansion we talked about before, right? Those materials are expanding and contracting at significantly different rates.
Exactly, and concrete shrinks over time, so that longitudinal splitting, or the shear force, essentially, when you have at a 90-degree transition point, it will split at that point. So it's just something to be conscious of. It's really the reason why you see diamond patterns around columns, and when you're on large concrete structures, it will crack. So it's just something to be aware of. And as you can see here on the lower right, that drain, that splitting will happen over time, and it doesn't take very long. And using systems that are hydrophobic as well. So if you do have joints or joint material anywhere it's starting and stopping, it's not only important to have hydrophobic materials, but hydrophobic materials that are able to expand and contract at the same rate of thermal expansion as dissimilar materials are. So here's just a bunch of different images of the ways essentially not to do it, using T's or joints, and you can see quickly how the difference in thermal expansion can delaminate a floor system. It doesn't take very long to do it.
Right. Just real briefly, because we don't have much more time, loading classification, I think it's important to note that the load classification for drainage is not necessarily the drain, it's rather the grading. That's what gets tested for weight loads. Is that right, Scott Steinler?
Correct.
Okay, so Scott, tell us about this and what this is doing to prevent those pictures that we saw earlier. What's happening here?
Well, I believe Scott actually covered that. So really one of the bigger issues is going to be the rounded corners, that's going to prevent damage to your monolithic flooring system. We've got anchor tangs that are available on some of the drains that, so the drain becomes more integral to the flooring system itself. Smooth grates, non-welded grates, so you don't have weld seams and areas like that for propagation of bacteria. Your channel design, you want that to have a high flow rate. You want it to self-drain so you don't have standing water because, as we discussed, that's, nutrition, water, you need those to breathe life. Go ahead, Jimmy.
And a couple other points, and Scott Garska, you can kind of accelerate this, but inside of a shoulder of a drain or a channel, typically there's a shoulder that looks like this. And the contractor is supposed to come in and fill this empty void with some sort of grout. And typically that does not happen. And if this is open in any way, water will find a way. It'll seep here and start to erode the ground underneath it. That's true, correct?
Almost every installation where we're doing a floor where they ask it be done in a field to fill that shoulder, which is evident in that top left picture with the yellow, that never happens. Maybe 1 in 10 you see a plumber actually doing it. But if it isn't done, what happens is that drain will eventually, or that shoulder will eventually crush or cavitate, thereby leaving a void against the floor system. And we get calls all the time, oh, your floor is failing at the drain. And usually before our project engineer gets in the car, we already know the drain probably moved away from the floor, not the floor moving away from the drain. So I think having anchor tabs and having that void filled from the factory is critical to making sure you have longevity, whether it be in healthcare, food, any type of facility.
Right, because that problem happens everywhere. It's not limited to these specific industries.
Yeah, I would say it's the rule rather than the exception, unfortunately. And the same thing is true when you're trying to do your details for the floor. We want to make sure that we're keying everything into the drain or termination point. It's really the weakest part of any system is where it's terminating. So keying everything in is really critical, as you can see here in this detail.
Hey, guys, in the interest of time, I think we're approaching that 1 hour mark. We do have a few slides left. I think we've talked Scott, would you say that we've really kind of covered most of these issues on a high level? Yeah. So at this point, I think we might want to go ahead and talk about, the content of slide 65, where we're talking about the long-term investment involved in the hospital. Unless there's something that you're seeing here that you feel we really need to spend more time on, I just want to be as respectful of everybody's time as we possibly can be.
Sure. No, I think we went over pretty much the content of those slides.
I would say so as well.
Yep.
So, we're talking about complex buildings with many demands, the durability, the hygiene that's necessary, installation, sustainability, something we didn't talk about, low water consumption. We're looking for things that are recyclable, eco-friendly, and the ROI. When you're talking about a stainless versus, a comparable steel system, you're talking about a system that's probably going to last you 70 years versus 7 years. And we'll go ahead and advance to the next one if you don't mind. And what's interesting about this, now there was an article I read, out of Preventing Microbiological Contamination. This was out of Food Manufacturing Magazine. We know that although the initial upfront cost of purchasing this hygienically designed equipment it can be very expensive, the benefits of doing so are multitudinous. It helps to protect the consumer welfare and a company's brand reputation. And we've already discussed it in hospitals. This can help prevent you from actually hemorrhaging money from the fact that you're not being reimbursed for patient care. So that's not it, though. If investing in these hygienically designed product inspection equipment, it can lead to long-term cost savings and increased operational efficiency by allowing your runtimes to be extended, shortening your clean times, reducing chemical cleaning and water usage, and lowering your overall maintenance costs. So with that, I think that pretty much covers everything we had. Scott, did you have anything you wanted to close with, or are we good there?
No, I think we're good. I appreciate the time everyone has given us. Really, I think when specifying or looking at these types of systems, feel free to contact any of us. We could definitely help you out. But I think what we've seen is, especially with COVID and other foodborne illnesses or recalls, it's so critical that we get the details correct for long-term performance. And that's really what I'm focused on. I know Scott Steinler is extremely passionate about it. So, if you do have any questions going forward, if anything comes to mind, feel free to contact us. We can help you out.
Yeah, and thank you for allowing us a little more of your time than the hour. As you can tell, we're all very passionate about this stuff. And also, it is a larger problem than I think people in large understand. And so hopefully you took away more understanding of where this problem is coming from, how big the problem is, and what you can do to mitigate the risk.
Yeah, unfortunately, it's a large and very expensive problem, too. But, it's not insurmountable with a little bit of education and some things that we can do. Just minor things, as designers to kind of curtail these problems and really serve our clients to the best of our ability. So thank you very much for allowing me to join you today. I appreciate it.
Yeah, thank you guys. We do have a couple questions that came through in the chat here, but before we get to those, and again, I appreciate you guys sticking on. Majority of you are still on, so that's great to see. But I just wanted to quickly mention two of our digital tools that we offer you guys. I just put the links to them in the chat box here. So the first one is Selexit. Selexit is our online configurator, and you can generate your precise optimal system configurations in the tool. It's going to help you accelerate your sizing, configuration, and selection process for mixing valve systems, ACVs, and snow melting systems. The other tool here is Spec Hub. So Spec Hub is our project specification tool. With this tool, you're able to create project specifications very quickly. It was designed to ensure you have the most accurate and complete product information for your complex projects, so you're able to stay on track and reduce any unforeseen issues that may cause delays. So the biggest benefit with this tool is its speed. You're able to quickly select and specify Watts brand products according to your building requirements and codes. It's going to save you time researching products online, as all the product info is already in the tool itself. It's going to save you time writing specs, plumbing schedules, and getting BIM files that you need. So what it does is after you're done putting together your project or spec, it'll automatically generate those documents for you to download and share that project information with your colleagues. So the biggest takeaway, for this tool, Spec Hub, is just that we believe it's going to save you time and just make your job easier. So with that said, I will get to the final questions here for the team. So does microband in plastic help reduce bacteria at all?
I can't speak to that. I'm not familiar with the product.
There's different inhibitors you can use with plastic that we see for resins, whether there's silver ion technology, microband, that's another type. It's kind of belt and suspenders in many ways, where you have, if you're picking a surface that's non-porous to begin with, it doesn't contribute to bacterial contamination. But as we've seen with PVC, the look of PVC on its face is not porous, but when you look on into a microscope, it is. So if we can reduce the amount of porosity to begin with in terms of the actual product, you really don't need microban or you don't need silver ion and things like that. But it's used as a secondary method if you do have that porosity, something like they put it in like a cutting board, just because we know that there's going to be inclusions in it that can breed bacteria. So you don't need it. It's belt and suspenders. If you're picking a better product like stainless to begin with, then you don't really need that type of system.
Thanks, Scott.
That's his question.
Thank you, Scott. That is all the questions we had come through. So I just wanted to thank all our panelists, Jimmy, Scott, and everyone who joined us today. If you have any logistical or specification type questions on Spec Hub or Selects or anything like that, you can direct them at me at gregory.jackman@wattsware.com. And for your technical and topic related questions related to sanitary design or anything we talked about today, you can reach out to Jimmy and Scott Silence, Scott Garska. All their email addresses are on your screen. So after this webinar ends, it's going to bring you to what we're calling our hub page, where you can learn more about our Blucher Hygienic Pro flooring and piping products. There are some videos. There's an ebook. There's a link to our food safety landing page, a link to our BlucherPipe.com page where you can learn more about our pipe, drainage, and channel stainless steel Blucher products. Also, in the next few days, a recording of this webinar will be uploaded to that page as well. There'll be a quiz there that you can share with your colleagues if they want to earn the 0.1 ASPCU credit if they weren't able to attend today. And we'll be sending you an email with that link to the hub page so you can access it that way. So if you want to reach out to your local rep, there'll be an option to click on that page as well to do that if you want to. So again, thank you all for joining. I know we went a little over, but there's still a lot of you here, so that was awesome. So thanks again, and have a great week.
Thanks, everybody. Stay safe.
Thank you.